Okay, before the break, we were talking about the idea behind containers. Obviously, this goes a long way. They're just introducing them here, getting that foundation, and then y'all can start researching and building on them. They're pretty easy to work with. And as far as coding, it's kind of like what we already do. I'm just going to write a quick example. I think I'll do a payroll example. But for your homework, just make up some program. Maybe use one from last semester. We haven't done very many big programs this semester, right? So something without a GUI from a previous semester, or make something small. It doesn't have to be something fancy. Or if you've done random practice, make something big, right? Whatever you have. Really, the thing I was looking for is make sure you have at least one thing to put in requirements.txt. So make sure you had to install at least one library to do that, because most computers these days have Python on them. So if we send a Python script, it's going to run on that computer. That's why we have to do our homework from GitHub through GitHub on this class, because pretty much every computer in our modern world will run Python as is, which makes it kind of a big security risk. Browsers are set to block downloading Python scripts in every way possible. They'll block you from sending the script, and if you get that through, they'll block people on the other side from downloading it. But it makes sense. That's a big security risk. With C++ or C#, Java, C family, any of those, we download it and it has to be compiled before we run it. Or Java, they have to have the Java virtual machine installed. Most of the C family at least has to be compiled before it will run. But that's not the case with Python. It's going to download and run immediately from the text file, which could be a big security risk depending on what that particular Python script does, right? So it's blocked, but we do transfer software. So when they set up the security protocols, they just put specific places, such as GitHub. It's like, this is a code repository. Code repositories are how we transfer programming code, like source code. So it is perfectly okay to download a Python file from GitHub without triggering any security protocols, because that's where we would expect to see it. Anybody that goes to GitHub and downloads source code probably knows what to do with it. It's not just random person in a cubicle that received an email that has a Python script attached, and they're going to download it and it starts running immediately on their work machine with no idea what's happening on it. Or in some cases, them even knowing that it's running. If there's nothing visible, or some people, it could pop up a visible window and they just move that out of the way so they could get back to their spreadsheet or whatever their job entails. So that's why we go have to do our homework through GitHub there. I can't remember what started that tangent, but Python scripts, we can just immediately transfer those. And yeah, I can't remember what I was starting to talk about. Sorry, little tangent, and I lost my.
You were saying that we needed to have at least one install at least one library that's not already included in the Python, and have at least one file in the requirements.txt file.
Exactly. You choose the program. Some of y'all probably have some big programs already that you've made, or could make some fairly decent sized ones pretty quick. But I'm just going to do a quick maybe payroll example for our software. And I'm just going to jump right into it. Well, we will need something. So while I start the Python code, let's look at the download stuff we have to download first. So we need to install Docker itself. For that, you can go search for Docker desktop. That's not what I searched for yesterday, but that'll find it. And download. So we actually want to download the Docker desktop thing on the computer. So this is what's needed. This is what accepts the virtual machine. So I guess that's like an interface. So in here we have the Docker desktop. And that's the interface to the existing operating system that we load that virtual machine on. So we know it's going to work anywhere we send it. but this is very, very common, so we can do this. And as far as cloud delivery, right, the cloud stuff's really nice from the developer side because we're in charge of the server sending them the application. So we have the programmer or developer is at least on the same team as the server administrator for there, not administrating that server themselves. So we would just install Docker there and then it sends across the internet. Maybe you just want to download it for Windows or whichever one of your Apple machines you have, the appropriate chip, or a Linux machine. Just download and run that installer, which I ran that yesterday. It's one of the installers that only has like 2 buttons because that's the traditional way to do it. And it hasn't gone away yet. So we will see that in class as well. But once it's installed on a Windows machine, then you come down here and in the tray, there's this little whale looking thing. That's the icon for Docker. We click that, we get the window and see all the stuff that we have going on with it. We don't really need anything from there because we're going to do it with the terminal. And after you install that, Docker is going to be an instruction in your terminal. So if you just type the word Docker, it'll do like normal. And we didn't give it enough to actually do anything, so it just pulls up the help menu when we type in Docker. So after you download and run that installer, whatever system you're on, you should be able to just type the word Docker and see the help menu or see what's there. So you'll need to run that installer first. I'm gonna put that in the chat room. Instead of just showing you all how to search for it, I'll actually throw it in the chat room so you can hit that link and download the appropriate one for your system and install that. And since we're going to be doing some other things, I'm going to use the regular text editor here. So we need a Python script that uses at least one external library. So I'm going to create a quick payroll calculator. So what do we need? 2 numbers, rate of pay for a terminal, not a GUI or anything, just the little calculation. A tip calculator, the program you write doesn't have to be fancy, but it does have to run. So make a program that runs. Rate of pay is going to be, well, we'll get that from the user. Input, how much do you make? I'll come back and do the other stuff and maybe go save this so that it yeah, this will work. I'll just go ahead and put it on save it in this folder for GitHub. I'll make a new folder, Docker. Yeah, I'll just put Dockerize. That way it's not the name of the software itself, but it clearly goes with it. Which matches the verb we use. So we're making, it's a Docker container, but we want to containerize our thing. So instead of the traditional installer, which haven't gone away yet, we still see those a lot in the world. So we will see that in this class. That's one thing that never showed up in a single programming class I took. And that made some parts of it what to do when the software is finished a lot harder than it should have been. So I always like to go over that in class. Some of y'all have seen that before. And then this is, I don't know, paycheck.py. And I always work from the inside out. So that's going to be a floating point number. And I'll probably put an emoji there to match the rate of pay. So import emoji, which we saw that earlier in the semester, right? That was one of the first things I looked at because emojis are definitely part of the English language. I'm wondering how long it's going to be before that's part of officially in Python. Because I get emojis all day long in like professional business emails. But like not just internal to the school, people I know that work here around the school, but like other outside companies. Where or might be trying to talk about internships for students and stuff. Professional business settings, and there's going to be emojis all over the place. It's part of our language. And we saw that before, so we need that emoji library dot emojize as a verb. If I close the side panel, view sidebar, hide that with a bit. Well, others, I don't think it's still not quite gonna fit. I maximize it, will it? Oh, well, maybe. And then we have that special symbol when we do that. So we do colon, then some sort of name like thumbs up, because getting paid is good, and then the colon for the prompt. And I think I need one more parenthesis at the end. Okay, all that's missing is the closing parentheses. It's behind the Zoom calls on the TV in the room, but there's the prompt and then the symbol for the emoji things, which I guess I could move those out of the way. Okay. Oh, well, actually, as I move those out of the way, I noticed both people in the classroom are logged onto the Zoom call, so they really need me to move those out of your way. So we get some sort of sentence in the input. And ours is, I always work from the inside out, but it's kind of what it is. So input, how much did you work? I guess this isn't really even inside out. And we could use an emoji on that. So inside the input, right before that string, emoji.emojize. Is it going to show up somewhere in our example? Yes, I'll use regular concatenation when we get the output, so you see how the emojize goes with the concatenation. The whole concatenation goes inside of there, in case I forget it in a moment. But I think I'm going to need to do it that way anyway. They're floating point numbers. The curly braces are great if we have integers and strings, formatted strings, but otherwise we have to do a whole bunch of extra steps, and then it's easier just to concatenate it. I think there's more than one way to do it. Tired face. That seems to go with that. So we'll throw up the tired face emoji when we're asking for how many hours did you work each week. And again, that is solely to have something in the requirements.txt file and to remind you all how to type emojis in your Python strings, because it's part of the English language. Now it's just payroll calculator. So if hours is greater than 40, gross pay is hours times rate times 1.5. I think everybody knows how this part works, right? Whoops, spelled that wrong. Gross pay, if it's less than 40, then it's just hours times rate. And little expansions go pretty easily. Like you can come up with just some basic make up a simple tax version, like I don't know, choose 3 numbers. If it's less than 700, you're in the low tax bracket. Less than 1,500, you're in the middle tax bracket. More than 1,500 a week, you're in the high tax bracket or something. To kind of simulate that more advanced part, if you want to, just to get good practice with Python. Same thing, you check the date to see if it's one of the days that a lot of jobs pay double time for. There's a lot of them, but for us, this will be okay. And then just print. Probably one emojis here. I'll go and type it first. Emoji.emojize. And then that string. So that will be plus gross pay plus this week, and then one of our emojis, astonished face. I do not know if that has a particular meaning or something. I don't really speak emoji. People send them to me all the time. When I send text messages, it'll be grammatically correct. And gross pay is a floating point number, so we can't just concatenate that into the string, right? So we could cast it as STR, which we saw last week is going to call the underscore string underscore STR method, or the double underscore REPR for representation. The difference between them, usually they're almost always interchangeable because most people put a string in representation. But depending on the object, we could have a numerical representation. If we do the string method, that can only return a string, and we can't do math with a string. But if our object is better represented as a number, with the REPR representation, we could send a string or a number. If you do that, then you can leave off the two string methods.
That's kind of, that would be really useful for this situation then, wouldn't it?
Yes, but there's not a the representation of that is different.
Only if we were trying to like put different numbers together within the string.
Since that one's built in, there's fancy stuff going on with representation.
Okay, I'm staying away from it.
We would use it in a match case statement. For many, many decades, it was never used, but the way match case is set up, which is not the same as switch case, the syntax is very, very similar, and it looks like we can swap out some of our if-else structures with the match case, but it is actually something different, and we would use the internal structure of the data. It actually does something really, really fancy. But I only ever use it as an alternative to the switch case, but it's only been there for a year. It was only introduced in October of 2021. Yeah, so it's only been there a little over a year. For a long time, we didn't have a switch case in Python. This is the way I usually do it. Instead of the curly braces with the F thing, I just do the format method instead of the string method, and then say how to format it. So a decimal, then 2 places on that floating point number as a string. There are other ones. Y'all know how to check the documentation for the other things that would go in there. But usually it's, if we're formatting our number, it's going to be just a couple of decimal places, like currency, throw the money, $sign out front. We don't have the stuff like the C family of languages. We can't do like Java. We can't check this geolocation and calculate the dollar amount with the right symbols when they're in America. And then they get on a plane, fly over to England, and then we calculate the pound amount equivalent to that dollar amount in the US. We don't have that in Python like we do in Java, but we can at least, this is the way I like to format stuff. We can mix and match stuff. We don't have to choose just one. Find the one that makes the most sense to you. Because we all think different, right? We're all unique individuals. Some of you may have seen this method before and just absolutely disliked it because it's completely different than the way you think. But that's the way I usually go with formatting strings. And then we'll throw in one of the happy faces. That's the happy face with like the mouth dropping open and the eyes super big and the super, super happy face.
Unless they were out sick that week.
Yeah. Yeah. That's a different thing. But then you wouldn't be punching your numbers in the payroll calculator. So now we can run that and give it a test. So I'll go over to the working folder, documents/delete. Then a folder called get stuff. And then a folder called dockerize. And here's that thing. So our instruction to actually run it is Python. On some machines, you might need to type Python 3. If you're on a Mac, you need to type Python 3 because Python was used to build Macs. So Python 2.7 is still there. Or if you have several versions, you might need to type the exact version. So if you have like 3.7, 3.8, and 3.11, you might need to type the exact version. It would just go right there. So I could also type Python 3.11 because I know I'm running 3.11 on this machine. Or if necessary, throw in the last one. I don't know what the last number is on the one I'm running here. I could look real quick, but we can type all of that. But there is a default Python that's going to fall back on. Whoops. Yeah. So start the Python interpreter and run paycheck.py.
Does the default one use the most, the latest one, the latest version?
It's whatever we set it to.
That, the latest version that we downloaded, or you said it's whatever we set it as default?
Let me open this. If we go to environment variables. So I was anymore, I go to the system about, and then advanced system settings. And under the advanced tab, is this button for environment variables. And then there's this variable called path. And path is all the programming languages that the machine knows about. So the one nearest the top. So if it goes down this list, so index 0 on the list, index 1 on the list, index 2 on the list, the one with the lowest, the version of Python with the lowest index is the default. So if you don't like it, you would just move it up or down that list. So we have the button over here. So if you had 3 versions of Python, you'd want to use the move up and move down buttons.
Oh, okay.
And to figure out which one is going to open by default. That help?
Yes.
Which, if you were doing something constantly with Flask API, remember on the homework to do tonight, we have to type that every single time we open the terminal. And there's different ones. Did everybody take note of what it was for your machine from lecture last week? I'll throw that up after we wrap up. Because both videos only show the instruction to do it on a Mac. It's a different instruction for a Linux, and it's a different instruction for command prompt or PowerShell in Windows. So I want to make sure you know how to set the environment variables. But if you were constantly doing things with Flask, not just a quick test before you load it on a server or something to do your API, you would probably just add those Flask variables to the environment variables here. But when we do it right in the terminal, it makes a temporary one. But that's how we get to the different versions of Python. And then that variable is just a big list of paths, not that one that highlighted, but file paths like that point to Python interpreters. And we would just choose which Python interpreter we were. So it looks like I forgot to type something. Oh, I knew there was a float there, so I put 3 closing curly braces, but I forgot to cast that into a floating point number. So I need the other opening parenthesis. That's really unusual. I must have started talking about something else, and then my cursor was over there, so I typed the closing one. Because I'm not sure if I've ever forgotten an opening parenthesis before. I've forgotten lots of closing ones, yes.
Did you mean to put rate of pay down in the if statement also?
Oh, yes. Now, are we good to run it? See if we get error messages. Run that last command. Oh, there we go. How much did you make? And a thumbs up on that one. Oh no, 23.45 seems like a good rate of pay. How many hours did you work? Let's say, probably should have used a number easier to check, like 20. But let's say 30 hours, 30 times 20 is roughly 600. And then the other 30 times 30 is 90, and 30 times 45 would be a few more dollars. So a little over 700, 703.50. So that seems about right. I'll do an easier number to check this time. So let's say like $10 an hour. So kind of a lousy job, but if we work 45 hours, then we should get 400 plus 5 times 15, which would be 75. So 475. $675. Wait, 10 times 40 is 400, right? And then that leaves us 5 hours. Oh, So something went a little bit wrong there. Anybody see what I did wrong in the calculation? This is one of the most common mistakes to see anytime there's a payroll, anytime this shows up in homework assignments.
Okay, rate of pay times 1.50. Oh,
This, our first 40 hours,
it says it 41. Oh, wait a minute. No, it's 40.1.
first 40,
40.1.
almost, I think you're thinking the right thing. So the first 40 is regular pay. Then plus, oops, our hours minus 40. So we only get the extra we only get the time and a half for the extra hours. That's one of the most common mistakes to make. So just a quick reminder on that.
Okay, but I'm trying to understand it's hours minus 40.
So if we're 45 hours.
Oh, okay. Your hours minus 40 is 5. Because if we put in 45 hour, then we're talking about, we only want to deal with whatever the hours minus 40. Okay, I got it. Sorry.
Yes. Some people like to do this as one line instead of a selection structure, because if we did this, if we did hours minus 40 times this, we either get a positive or negative number, and then you can deal with that positive or negative number. I think it's a lot easier to keep track of in a selection structure. But there's ways to do it in one line using that and then checking whether it's a positive or negative number. But let's see if that gives us the right number. It seemed about right for under 40, but maybe I should check with an easier number to check. So let's say $10 an hour, and we work 32 hours, we should get $320, right? Okay. And run that again, make $10 an hour, and if we work 45 hours, we should make 400 plus 15 times 5 would be 475. Oh, if not for the typo. Fix the typos and then see if that's what we get this time. 1045, 475. So that's given the right numbers. Like, all right, our software is finished, it's debugged, it's ready to go. Everything's working great with it. That's where we would traditionally make an installer. I guess technically, we just need to give them this script, but that's not how people install software, right? If somebody that didn't know anything about or didn't know much about computers, if we gave them just a Python script, they'd be like, what do I do with this? They're expecting an installer where we click on it, it opens up the window, they walk through all the steps, or that's an exe installer on a Mac, or a PKG installer on a PKG installer on a Mac, or an exe installer on a Windows. Goes step by step through the wizard. We also have the MSI for Windows, or the IMG for Macs, where you open it up and there's one click and then it does the whole thing. You click once and then wait for it to finish. That's the MSI on Windows, or the IMG installer on a Mac. But that's what people expect. So we want to create one of those, and we will see that in this class before long, because those haven't faded away. But the new modern option that's really nice, especially for the cloud, is the Docker stuff we were talking about. So instead of making that installer and putting it on their machine, let's Dockerize it, put it in a container, and then there's a virtual machine that's going to run no matter where we put it. Instead of adjusting our software to fit whatever operating system the user has, we're just going to send the operating system with our software.
The virtual machine.
Yes. So then we don't have to worry about any adjustments afterwards, and we have control over it all the way.
And they don't need to know anything about the software. They just have to know the program works.
Yep. They just need to know where the icon is to start it. So we're gonna do it in the terminal. That's stuff easily built on later. Or you can Dockerize it and then load in and then load in the Dockerized version. Or Docker isn't the only one. The containerized version, put it in a container and load in that container from the installer. And they won't know it. You ever look at the source code of when you install software? Maybe later, right? Now that you're software development students, you might get in there and look at the source code. But you'd more likely go to GitHub and look at the source code where you won't mess up the version on your machine. Right? They wouldn't know how it's set up. They wouldn't know it was a container. So we could put it in that traditional installer and then everything's good to go that way. So we need our manifest. So I'll create a new file, Control N, and save this in the same spot as requirements. .txt.
You lost your U.
Oh, thank you.
Mhm.
And these are all, every file we're getting ready to make is for an automated process, so be careful with the naming. Requirements.txt. And I'm going to delete the other one so I don't forget about it too soon. And documents and delete and get stuff and Dockerize. And this one looks like it's too short. So there's those two files. Anybody remember what version of emoji we used? I think that video I put up there pointed it out nicely. Because he typed in the library, he's like, I felt too lazy to look it up. So this would work. It'll go download the emoji library. But 3 years from now, will it still download the same emoji library we used?
It could be updated, but for now you can just write emoji.
If we just write emoji, it's just like when we say pip install emoji versus pip install emoji version 2.2. We could specify a specific example, but if we just say emoji, it's going to install the latest one. But hopefully our software is going to be around, so people don't need to look for that. So you could go Google, see what the latest version is. Pip freeze pulls up all of your stuff. This is one place where virtual environments are really nice because you start with that blank slate. So if you use any extra libraries, that's all you would see in pip freeze, and you just put this right, and then just do the redirect. So like pip freeze, clear, pip freeze, overwrite requirements.txt or append to requirements.txt. So one, I guess they're like arrows here. One arrow overwrites, 2 arrows appends. And we can just add everything on that pip freeze and do that, but that doesn't work in my main version here, but that's great on, I think both of the videos for APIs did that, didn't they? Anybody watch both videos? That's one of the big advantages of working in a virtual environment every time. You also know how to do a virtual environment. We don't need to keep doing that in class. Need to look at what that is. I know what it is. It's 2.2.0. But if nothing else, we can pull this up and see which version of emoji we're using because they're in alphabetical order.
And pip freeze shows us all the libraries that do not already come with Python. Okay, good. Because I was like, am I supposed to know what? Okay, so pip freeze to look it up, and then pip freeze forward arrow append, that is going to add an appended or something like that. And then okay,
It's kind of like typing, only specific for text writing. So instead of typing to another instruction, we're going to send it to the explicitly write it in the next instruction, which will be a file. But look at all this stuff here. I need to put all of that in there. So in a virtual environment where you only have like the 2 things used, then that's perfect. That's all you see. But for the whole one, you probably want to do
2.1.
So I'll just copy that, paste that over here.
Okay.
Need for the requirements, I think. We can put an extra line break. I always like to do that. I don't know why. It doesn't really make any difference. It just doesn't do anything when it gets to the last line, but I always put an extra line there. But so we need that library. And there's one more file we need.
Map.
So that's what we need. So we're going to install this on the computer. And then requirements is to make sure, well, before we install this, they have to have this installed. So
Hmm.
that's what this file's for. And once that's there, they can run this. So that's the two files as far as Python goes that we need to run our program.
So it's gonna need the emoji and it's gonna need this file,
'Cause this is-
paycheck.py. Okay,
That's our software. And then the requirements is just a check. Do not install this unless somebody has emoji version 2.2.0 installed. Because it might not work. It'll just crash in that case. So that's what we need for our software. So now the Docker part. So I'm going to save this, and this is called Docker file with a capital D. It has to be called that, no extension. So just Docker file. If your text editor automatically puts an extension in on there, just come back through File Explorer or something where you can erase it. So Docker file, one word, capital D, no extension. And again, it's like requirements. It's for an automated process, so it has to be exactly that. And then these are pretty easy to. This is gonna be nice. Y'all are probably expecting a lot here, right? It's like, okay, now we have to create a virtual machine, load our software onto a virtual machine. Say what language to use to run this software. That's first thing. So your first instruction always has to be a from. So from, and then from refers to the language necessary. So it's basically like a shebang. So everybody's seen a shebang for bash scripting. In bash, we always, or anytime we write if we don't want to say, I'll put it in the Python file. I can do it here. When I went and ran this, I said, use the Python interpreter to run paycheck.py. I could do that over here in the file. Put that in a comment, like, quiet for a comment, and then exclamation mark, like loud bang, so that's shebang, and then say what to run it with, which is the Python interpreter. C:/user/frank/app data, I think is written that way, /local/programs, and then so on and so forth. Y'all have seen where Python's installed. So we have to type the thing to the Python interpreter. And then in our terminal, we would just type the file name because the script already says how to run it. The script itself says to use the Python interpreter. So we have to do that with our Docker container. The first thing is from, and then how do we run it? We're going to use Python :3. That'll work. So Python version 3, any version 3 will be fine. And and Docker is going to go get the latest thoroughly debugged version of Python 3 from the repository. If you wanted something earlier, like we wanted to go to an earlier version, you'd want to put the 0.8. But we're on the latest version of Python, so we just do 3, and that's the thing about Docker there's that continuous deployment, continuous development, continuous, what was the other D one that showed on Wikipedia? I always forget the third one, but they mean the same thing. The continuous development. Deployment's the one I think makes the most sense. We don't do version 3 patch, version 3 release 11 patch 22. We just do the software. And then whatever the latest version on the repository is that's what it's going to use. It's going to go grab the latest, newest version, and we can make changes whenever we want. And then people will get that latest version. So use Python 3. And I'm putting the Docker keywords in all capital letters. I forgot to check whether it has to be case sensitive. I don't think it's case sensitive, but I always type it this way: capital letters there, and then the other part I treat as case sensitive, so like file names and stuff. That way you can tell what the keywords are. So we start with our from, which is saying how to run this piece of software. Then we need work dir, and this is for the virtual machine. What's our working directory on a virtual machine? And I'm just going to type slash projects. Slash payroll. That'll work. So that's a folder, and y'all probably recognize that's as some sort of something Linux or Unix, or well, one of the ones that ends with it, Nix, not Windows, because we don't start with a C, which means it's going to create a Linux virtual machine, which would probably run, for all intents and purposes, going to be identical to what we would do for an Apple virtual machine, but Apple is a very proprietary thing, right? We didn't give Apple any money for this, so if we use that notation, we're talking Linux, not Mac.
Do you teach a Linux class?
I don't teach it, but there is one that runs. I did ask the lab tech to create several Linux machines. So if you're remote into the GRE labs, there's four Linux machines that you can use. Yeah, we'll have plenty of time. Let's look at how to log on to those after we do the Docker stuff. I was anxious to do Docker. This is the first time I've got to show it in class. I've mentioned it, but not actually shown how to set it up yet in class. Okay, so we know what language we're using. We know where we're working at, where we're running the program at. I changed that a little. I went ahead and added an op folder. So operations, that's one we quite commonly see in payroll. So the payroll operations folder is where we're going to run paycheck.py. And that's the next thing we need to do. So we need to copy paycheck.py from our current directory. So that dot again. So paycheck.py, and you'll find that in the same directory as the Docker file. Okay. They're saved in the same spot. So dot refers to this folder. It's like, okay, you'll find this script in this same folder. We don't have to type in any further thing. You could put it somewhere else, but you will almost never see it put somewhere else because we don't want those separated, right? Once we create our Docker file, that goes with our Python script. So we never want them to be separated again. Otherwise, it's like when we no longer have an image that our GUI depends on.
So that dot is current directory?
Yes, requirements.txt. Again, we'll find that in the current directory. So there's the two files we actually need. Where to run them at and how to run them. That's everything we need for a piece of software, right? Now we can start running stuff. So run pip install recursively requirements.txt. So whenever we install something else with pip, this is the thing that automatically gets called. That's why it has to be called explicitly requirements.txt, because this instruction right here is built into the Python interpreter will run this instruction right here. But we can run it ourselves since we're not really installing anything else there. And now at this point, it has the virtual machine, has a copy of our software, it has all of the dependencies. I guess that should go in the picture as well. Our software depends on stuff. I'll put that in a big triangle with a D. Depends. So a triangle like the warning, red warning symbol. Okay. We can't run it without our dependencies. Not depends, dependencies. Which, oh, that fit out nicely. It didn't quite flow over into the picture of the original operating system because that's a really easy one to miss there. But now they got the emoji library installed, and they got the software told where to run it and how to run it. So now we just need to pass in that command. So CMD, not for Windows command prompt, the abbreviation for command that we're passing into any terminal. And it's going to take in a list of commands, which we've already seen them. Python is our first one. What's that? And it's going to take in a list of strings that get passed to the terminal. So Python is the first one, and no spaces here. It will add the spaces. So make sure you don't put spaces in your string. It'll actually go type Python in the terminal, and then it'll type payroll.py, but it could be somewhere else. So we need to make sure and say the current directory. And to do that, if you do /, that means from the current directory. Payroll dot, right? So dot is the current folder. So into the current folder, and then / the same way we would type, right, if we had the whole address, C users documents / payroll.py. I'm not going to try to say that whole thing right now, but
Yeah, I noticed you did that on when you had your website up. I was looking at your code and you had that for your menu, I think.
probably. There's lots of different ways to do it, but as long as it makes sense what to do. Yeah, that's how we refer current folder, but then once we get to that folder, we still need / file name. So not new syntax unless you haven't seen the dot before. And that's it. That's everything we need right? We told it how to run it, or what it is, how to run it, where to run it, all of everything that should be needed. So, well, if you got Docker installed, there's things actually here, you could do it all. I'm just going to do it in the command prompt, but they do kind of set that up. So one thing, so there's a bunch of stuff we can do in Docker. Let me see, Docker -ps. Oh, whoops, that's not PS. Docker -ps. Do I have anything go? Am I forgetting the wrong, taking the wrong letters? Clear Docker images. So I have a couple things. So whenever you get Docker installed over in your terminal, try this. Docker run hello-world. Mine's going to run quickly because I apparently already ran that. Notice how the container's there. If you run that for your first time, it should take a few seconds because you'll see a message here that says, hello world, not available locally, checking the repository. And on the main Docker repository, there is a hello world to do that test. So you will see that the first time you run that, Docker run hello world, it'll tell you it's going to download it from the repository, and then you'll see this output after enough time has passed to download something from the internet. And then when you run it again, it'll be like this. The container, the application is already on there. It's already grabbed it, so it's going to use that local one. Until you clear it out and stuff, y'all can dig through that. We're just taking the first steps with Docker and seeing what to do on it tonight. We'll probably come back to it. So we have the instructions on what our software is supposed to do. So now we're ready to build our container. So Docker build -T stands for name. I have no idea why T stands for name. I pondered on over that for a while. thinking maybe it's from another language, but if it was from another language, then we wouldn't have English words like build. Or Docker is actually an English word. It's an extension of doc, right? Like where it both parts. I have no idea why T stands for name. It bothers me every time I type it and it makes me pause. Like, why does T stand for name? It doesn't make sense because it shows up in other places like TI and IT. Those are other parameters that T still stands for name. But whatever, I'll call this paycheck. All lowercase, one word. And Docker requires, oh, what did I miss? Oh, whoops. Anybody have a guess on what I missed? So I told it build something, give it the name paycheck. I didn't tell it what to build, right? So once again, that dot, the current directory, because I'm in that Dockerized folder. If you're somewhere else, just go to the folder where your Docker file and all your script is and stuff. So build something with the name paycheck, and you'll find all the files in the current directory. We run that, building that. And this one's kind of nice to watch. If we look, step 1 of 5 is done, all of those are done. It's down to the last step, doing that library. Well, I did one this time. So yesterday when I was getting ready, there was probably 15 steps where it was doing things with the SHA encryption. It is very, very secure. So, and it is kept that way. So in general, if you use Docker, you don't have to worry about security. Like we hear secure code. So that is one a nice short sentence to answer the secure code question. Use Docker, because Docker should be the highest level of security there currently is, right? I was talking to somebody about this earlier today. What's the point of 5 years asking security experts for 5 years of experience? Cybersecurity changes quickly. Just because somebody has 5 years of experience doesn't mean they know all the breaches from the last month. There was a lot in the last month. VPNs were shown to be not secure, and that's been their go-to for years. Cybersecurity people would say VPNs. Oh wait, VPNs aren't secure. Never mind.
What makes Docker security so great, and how does it get updated, and who's
They stay on top of it, and it's on the repository. So the same way it's pulling from the latest version of the repository again. The continuous integration, continuous deployment. As soon as there's a security breach, and as soon as there's a patch for it, it goes into the latest version of Docker, and then that's what gets pulled when we run the software.
okay?
We're not doing a version that was published 6 months ago or 6 years ago. When we run it, it pulls the latest version. So you're in that small window between when a breach happens and when they fix the breach, which is just kind of bad luck if you run the software at that point, right? Because the first thing they probably do is put.
You mean if you run the software in that teeny tiny window?
Yeah.
Oh.
That's all. Between when there's a security breach and between when they fix it, it's a very small amount of time. Because at the very least, they're going to find a workaround, right? They might not have a full fix, but they can start doing stuff immediately and change what's on the repository. So security experts are dealing with it. So that's an easy answer to the secure coding question, is use Docker. We did one line, it just encrypted everything in SHA 256. So 256-bit encryption on their software. We didn't write that, but now it runs with 256-bit encryption. That was nowhere in our instruction, right? But it definitely did that. So that's what we get from Docker build -t paycheck, and then doc. Remember where to tell it where to look. I forgot that. So after we build it, then we just say Docker run -ti, and again, T stands for name and I is image. Oh, actually, I can look at that. If I did Docker images, you can see there's our, there's payroll. That's from when I was getting ready yesterday. And there's the one we just made, paycheck. It was created 3 minutes ago.
Unless they're calling it T is like the title of it, and then the type, the name, the image title, or
Maybe that would make sense. But if you look at the label on the table, it goes under repository. And then when we create an instance of it, it gets a name. But it randomly generates names. We usually don't need those. We usually need, if anything, the ID from it. But we haven't ran it yet. I can't remember the command to remove those. Every video that talks about Docker and that the assignment links to will show you the command to remove those. I'm drawing a blank on what letter it is. It's Docker PS-1 letter, and that gets rid of everything there. But I can't. I'm drawing a blank. So Docker images shows what it is. So shows which images you have. Okay. Has anybody worked with virtual machines before? We download that ISO file. We download an image of an operating system and then load that in the virtual machine. So that's what we created. That's what we just built. We built an image of a virtual machine, and now to run it, we do Docker run -pi. I guess title would make sense, but title didn't show up anywhere in the labels on the boxes or anything. And then the name we gave for it, so we called it paycheck. And if you put spaces in the name, make sure you put quote marks around it here. And then, so your installer would get up to this, and then you just make a icon, put a picture somewhere on the user's computer they could click on, that when they click on it, it runs this command. Because that's what all the icons do, right? Every one of those pictures in Windows just calls a command, a PowerShell command in the background. So you just set it to run this instruction whenever somebody clicks on the picture that you gave them, the icon you gave them. And when we do this,
got your dot, I think. Did you forget your dot? Run TI paycheck dot.
oh, I typed something wrong when I built it, didn't I? Wait, where's my Docker file?
That payroll?
Payroll.
Doing the paycheck.
Slash. Actually, I'm gonna take that, all that out of there. I'm just gonna, what did I do in my example?
You have payroll.py on line 10.
Online. Oh, yes. Op/payroll, that's the folder we're gonna run it in, but ours is called paycheck.py. So now we need to go rebuild that, which I need to remember the clear command. Docker erase image. Oh, remove image. Docker PS-A. So I didn't know I need to do this. So I have to print out all of the running ones. About a minute ago, that would be this one. Oh, so here's the ID, and we need that to, so grab the container ID. If I pull up Docker images, you can see that ID matches the ID here. IDs are unique. So we need that we need the unique one, because we could have we could do multiple images with the same title, same name, same size, created on the same date, give them the same tag to link them together. But the ID has to be unique. So to remove them, Docker remove and then paste in that ID. And it spits out the ID back out. And if I run Docker images again,
It should be gone. Let's see, 290.
I guess that is the wrong ID. Maybe that goes, there's the other one. Docker PS-A. Oh, that ID.
It's not there. It was 290. See the last digits, so it removed.
Oh, so I guess that clears it from the running one. And then over here is a different ID. So Docker images, I thought it was the same ID, but apparently it's not. And I'll grab this ID, copy, and Docker, the normal command for remove. Oh, it's not that. Build, open, remove unused images. Okay.
Do you think it'd be an issue that we remove that other ID?
It shouldn't be. That should make the prune one work. Docker image prune. Maybe that's what I need. Image prune. Remove all dangling images. Yes.
At least there's a warning to make sure.
Well, that's not, I can't remember the remove command. I didn't think that looked right when I saw it. How to remove Docker images, containers, or volumes. Should be some copy and paste. Oh, nice. DigitalOcean has great stuff. Docker system brew, removing Docker images, Docker images -A. Oh, RMI. That's right. Remove image is RMI. I didn't think that looked right when I saw RM. So I think it's still on the clipboard. So Docker remove image, then paste in that ID. And then it says it deleted it with the SHA, shows the encryption and all that, the hashing. So now, images, it's gone. I guess I can remove all of them. Control copy, Docker RMI, and then that one.
Oh, that's nice. Images being used.
Those are still running apparently. I should probably stop them from running. I'll get to that later. We have to build this again, which is the instruction we need to remember anyway. So build -T, we'll call it paycheck. Let me clear the screen and act like I didn't just make the mistake I made 5 minutes ago. I didn't just do, I'm gonna act like I didn't just do the same thing that I did the first time, -T, call it paycheck, oops. And then dot, that it can be found in the current directory. So it goes through all the builds and notice how it went a lot quicker that time. Because it just downloaded that stuff from the repository, so it didn't, nothing has changed on the repository since then. But next time there's a change on the repository, it'll adjust stuff. Your mic's muted, Tiff. I see your mouth moving.
Oh, no, so I was reading that, use Docker scan. I was talking to myself. I was just reading that line.
Oh, okay. Yeah. So that's what you're going to do for the homework. Now it should run. So Docker run -TI. So -T is when we gave it a name. Then we created it. So now it's -TI for image paycheck. And we see the prompt from our Python app now. So a different way to run it, but again, this is the command that you would put into, that you would attach to the icon that somebody's going to double click to start the software. And it goes a lot further than that. This is just introducing containers, so I can do stuff with them. And then we could punch in some numbers, right? 23, 45, work 43 hours, and then see how much the paycheck's gonna be. That part, we already tested the software. We knew the software ran. But see how easy it is to set that up with the really great security, all the building stuff. I forgot a couple instructions. DigitalOcean is great. If they do one tutorial for Docker, they have lots of tutorials for Docker. That's one of the sites I would recommend going to quickly. You notice they have a copy button for every instruction on the tutorial. But don't just copy, make sure you read the paragraphs. And they don't have extensive reading, they're not bad, but they're consistently great tutorials. They explain what needs to go on, they show diagrams, make it very, very clear. And have the copy button, so if you're in a hurry, you just go over and copy the code and paste it in. And then come back and read the paragraph later. It's like, okay, that worked, now I need to figure out why that worked. Anybody have any questions about Docker? Very easy to use. So you can see there's not much to it. Create your script, create your program. There might be several files involved. All the files and the requirements or dependencies. And then just set up these sort of instructions. And you can probably guess quick that if it was a really big piece of software, all that would really change here is the copy command. We'd have a lot more files to copy in, but we still have a definite starting point. We still do run pip install requirements. We're still running it with Python 3, making up some working directory. So if we had a great big huge piece of software with 50 Python scripts involved in it, all that changes is that copy section. Really easy to make Docker stuff. Let me close out of this. I'm gonna leave that open for a second. If I go over here to the whole GUI, oh, look at this right here. So here's that. There's that one. We can come in, get a bunch of statistics about it, see all that stuff. Or nice little run button. Start that. I don't know where it runs at. Is it running in PowerShell? Nope. Yeah, I have no idea where it's running at here, but somewhere over here we should see
Does
it.
it show it in the task manager? It's running right now. That's probably too much. to Look at.
Yeah, I don't use this one very much, so I might have to look into where it is here, but I guess we probably should have opened command prompt. I didn't see anything else open. I know where to put it in the terminal. I have no idea where it started running. There is a run button there. I know the instruction for the terminal, so I always put it there. Any questions about Docker? Very, very easy. So needs to be back on GitHub so we can work with it. So those are done. And I just went ahead and worked in the repository. I just brought the repository down here. Why is that not clicking? Okay, so this seems to, maybe it's messing things up. It's stopped running, didn't it? I'm just gonna do this, delete. Because we have the files, we can recreate it with no problem whatsoever. So we designed the image, so that's like the template, the object or the class, and then we instantiate a container from that. So that's like the object. And so if that analogy helps, we design what our software is going to be. That's the Docker file. And then we created a container from that. So maybe we need to delete all these first. delete, delete. It's at least easy to tell where the delete button happens from. And now with all the containers deleted, we can come over here and delete these because we have the stuff that we can recreate them very, very quickly. Clear all that out. Maybe that's why this thing was not responding. Do other things work? Okay. I was hoping it would pop up a message saying that I could close it or something. Explorer, there it is. Windows Explorer. Okay. That was weird. It didn't kick me off Zoom or anything, did it? Can you still hear me? Okay. Still see my screen. It didn't even, the end task button went away. I have not encountered that before. I'm not sure why, but I suspect it had to do with Docker, but I haven't encountered that problem before. So did that right in our GitHub repository, so we can push that back to, but only a local version, so we can send it back to the repository now. And this is what messed up the other day, right? Those things. So if I open terminal back up and navigate to that CD documents / delete. So there's our GitHub repository, or a clone of the GitHub repository. We need to push it back up there. We made all the changes, so git add. I'm in the current directory, so I can just use the dot to add all the files. Commit to that, so git commit -m, and the label we'll put on this particular commit is Docker stuff. Intro to Docker stuff. There is a lot more to go with it. So intro to Docker. We might see more. What do we got? 83 lines across 4 files. That sounds about right. So this is the part that failed the other day. Let me make sure. Git branch -l will say all the branches. There's only a main one. There were 2 masters, and it was trying to push onto 2 masters at once, but it can only push on. There should not have been a duplicate name. I don't know why that happened. You could change it if you wanted to. So check out branch. Oh wait, check out.
Yes, I guess because if there's a duplicate master, every master has a main.
Yeah. So let me put this on another branch. Docking.
Branch. Okay.
Oh,
Dot, maybe. Mm, docking.
there we go. Check out part of Git. Check out isn't a command on its own. Sorry about that. So now if I do git branch -l, there's a main branch and a side branch. And the side branch is the one we were currently selected. Git push origin main. So enumerating 10 objects, so 10 things, using up to 4 threads. So it uploaded that stuff. Resolving deltas, there was only 2 things that really changed locally, so that's all it uploaded. That's why it went so quick. It noticed that there wasn't much that had changed. Now, if I go to GitHub, we should see that second branch on there. You always want to do that. Always check out to another branch, and that way you don't mess up your main or your master. Because that's why I had to delete the repository last week and do that, because I kept uploading to just the default branch, and that is a really, really bad idea. You should never do that. I had to delete and recreate the repository last week, which means it's way down the list. Here it is, SDEV 220, spring 2023. Oh, it only has 1 branch. Oh, well. Type in the name of the branch you want here. This is the branch we're pushing to. I said push back to the main branch, so it pushed it back to the main branch, even though I said I was working on a different one just the step before. So if it did git push origin docking, it would have created the second branch. I have no idea how to have it at type main. Much better form to type to go on to the second branch or 1 branch. All we have is the main branch there. When we push it back to the repository, we do type the name of the branch we're going to. And even though the Docker branch was selected, it still pushed it right back to the main, because here's the new stuff. 3 minutes ago. And so you can see there's not much to creating a Docker file. The local machine didn't recognize Docker file to change colors, but GitHub certainly does. It knows what a Docker file is. It gets us some color, the normal color coding we would expect. Does anybody have any questions about that? So that's one you definitely want to work on and spend that on lab time. I did want to show something else before we leave here tonight. And I'm going to do this, cd dot go up a level, and then try to remove -r git stuff. If I try to do that in, whoops, remove -r git stuff, I'll pass in the command to delete it from here and get a bunch of error messages. It's protected. That's what those are from. So usually for the repository, I'll actually go in here and just hit delete button here. Like go in with the pictures and delete it so that it goes to the recycle bin, so it's not fully deleted yet. And we deal with those protection layers later in the recycle bin. I usually do that instead of the charcoal. So I mentioned Linux machines. So before we wrap up here, I wanted to talk about that. Let me send a file. I think it's in downloads. I sent it out to the class earlier today. Yes.
Question about on your GitHub where your repositories are. How did that commit message of intro to Docker show up on the storage and API file?
That file did not. Oh wait, that file did change. Because the first one we did was in that file. Remember when we did the reading from a URL?
But it's got intro to Docker on it too for the commit for that.
If I go in the folder,
Is that because it's just the last thing? Is that what that is? Is that the last thing?
that was the last time it was changed.
Okay, all right.
Or there's a button over here, history, you can see every time it was changed. I guess that just gives the history of that particular branch.
Okay, good. Good to know. Thank you.
So over here, I'm going to send out a document some of y'all might have already. So if you haven't heard it yet, programmers tend to use Linux machines a lot, right? Quite often. I know a couple of you all are using Linux machines. I've seen some screenshots you've seen me and stuff or shared screens. For the rest of y'all, you might want to start using them and ask the lab techs to set some up here and our GRE labs on campus, so you can remotely access those. Let me send the link. Here are the instructions for remote access to GRE labs. And here's a PDF, which should be showing up in your Ivy Learn inbox very shortly. I think there's a slight delay on those, but not more than a couple seconds. But I'll just open it here because I have it. So it's the instructions, really. You just need the first one here.
For Beyond Trust.
Yeah, we have to yet. Click that link and it goes here. And the big thing is do not use your username and password. We need to use better authentication. So make sure you come down here and click the SAML authentication. Is I signed in earlier today. It'll go to your Ivy Tech login, that green screen you see on Ivy Learn and My Ivy. That's actually Outlook Exchange. Emails are quick blast from servers. So email servers are a great place to do extra little things. Category called Radius. If you take networking classes, you might encounter stuff about that. But between sending emails, email servers have time to do lots of other stuff, like check passwords, because that's a direct comparison. Machines do that comparison, what the password you give them versus what the password is supposed to be really, really quick. So the sign in is an Outlook Exchange server. And then it sets up, and if it confirms it, it passes on to another server that just handles a bunch of the multi-factor authentication and all the security details. And then in the background, that has a much better level of protection. So that's why you need to use the SAML, and that will forward to I was just logged into My Ivy or Ivy Learn or one of them. So it kept me logged in and sent it there, but it'll use the better access than just passwords and usernames. For those who haven't come to campus, for School of IT, we have our own special computer labs. 157's new cybersecurity lab. It's finished except for the lighting, making it a dark room so it looks like a nice cybersecurity thing. But got classes going in there. I don't see it on the list, so they must not have put Beyond Trust there. But we have the 3 GRE labs. That's generic routing encapsulation. You don't need to know that. That's we have a tunnel inside of the Ivy Tech network, because the Ivy Tech computer rules access that we get is definitely not enough to learn IT thoroughly. So I had the lab tech set up a couple Linux machines. So if you go in here and into one of the GRE labs, 158, so I usually go, you should see a couple machines turned on and you can remote access any of the machines in the computer labs. Or if you're here in the lab on campus, you just log into one of the machines in the computer lab here. And I'll log into the guest account. So guest account, I just need the password.
And they all run on Linux, you said?
Oh no, these are Windows machines, but they set us up some Linux machines. So they're on this network, but we can't access them from outside these labs. They didn't give them a gateway to the internet at large, like Beyond Trust. Beyond Trust doesn't go to them. Beyond Trust goes to some of the machines in the lab. Actually, it goes to some machines sitting in a closet. We don't need monitors and keyboards for remote access, right? We just need the tower. We don't need a mouse on it. We can make big stacks of towers in a closet. But it's those towers are running the same thing as the lab computers here. So you have to access them, and the username, School of IT guest, SOIT guest, all lowercase in the chat room. And the password is Sellersburg. It's He didn't change it in the fall, so it's like Sellersburg 2022, but he put an extra E. If you know how to spell the words, the town name Sellersburg, take note of that E. I made a lot of typos with that one. I constantly forgot to put that in there because that's Sellersburg. Since I guess when I was 11 years old, at one point my dad lived in a trailer park here, and I've been typing that since I was like a preteen. So intentionally putting a typo in the name of the town was throwing me off. So, but once you're on here, then we have these remote machines we can access. So if I open PowerShell, these are just windows. Oh, and the first time, see this little icon here says SOID Help Desk. You go in there, there's the stuff to set up your account if you haven't done that before. For our labs, the instructions are written on there. Go in there, give your username, and please use your C number for the password. That gets used sometimes. Obviously, your password's openly available to anybody that knows how to look up C number, your student ID number. So don't put secure stuff on this labs. But we need that sometimes for the stuff we do in the classroom, or it can be looked back up. And if you don't come in the labs for 3 semesters in a row, when you get back in here, you're going to remember your password. Maybe not, but your student ID number hasn't changed, so we can look it back up. But if we go over to PowerShell, or still, and I figured out how to Zoom earlier. So remote access is a little bit different. No matter where you're heading into IT, in IT, you might need to do some remote work. And Zoom was one that caught me in this afternoon's class by surprise. Because usually to zoom in on PowerShell, I would hit Control+. But if I hit that now, that's going to zoom in on the browser on my laptop, not on the remote machine. So it would zoom in the wrong place. So you all can see what I'm typing. I'm going to go in properties and change the font. To like 24. Obviously, that's not necessary. Can you all see that on the screen better?
Yes.
A little bitty to begin with. And so once that pulls up, it doesn't matter where we're at. To access them, we can either use SSH or RDP. SSH is secure shell. So to do that, you go to the terminal. SSH. And then to the username and password for Linux machines is student user. Student user at 10.81.110.213 214, 215, 216. They gave us 4 machines. And it is straight the machine IP address. Nobody put any domain names to it. You put any even readable things. And I think that's the right address. I may have to look up. What?
SSH is not recognized.
It should be. Oh, I'm in the wrong PowerShell. Don't open the PowerShell that says x86. Regular PowerShell. Notice there's no x86 there. This one knows SSH. So open the regular PowerShell and then SSH, so secure shell, and we're going to access a student user at 10.
81-110.
110.
110.
I went in, and I might have this wrong because I didn't bring the little paper. The little paper that has it wrote down still in my office. I think this is the right one. Yeah, that's right. That's for the password. And the password is the same as the username. User. Which, when you type a password in a Linux machine, you won't see anything happen. You're typing it, but you won't see any dots or anything appear.
Oh, so you're saying the password was also that student user thing?
Student user, but you don't need
Okay.
that. So let me put that in the chat room. You do have to do this from our network here. It's not available on the
Student
outside.
user.
Um,
So password was just student user?
Password is student user, yes. So both of them are that, and then the IP address is 10.81.110.213 to 216. So 10.81.110 is the same on all of them. But we have
It's different.
214, 215, and 216 are all Linux machines that they set up for us to use. If you want to log on and use those, it's good practice with remote access. There's also a Windows subsystem for Linux. That's one I would highly recommend looking into. I will show how to install that soon. But this is on here, and then you have a Linux machine that you can just work with the Linux machine. See all the stuff that's there. This is the one I sent Apache on earlier. Sudo service Apache to start. Okay. So yeah, earlier today in the website development class, I set up an Apache server there. So at least from the same machine, which is in the same network as those, like it's plugged into the same switch or the same router. I'm feeling it's probably a different router, but same switch. If I go there here, and you want to, yeah. So you see this afternoon's class, we quickly set up Apache servers on their web pages there if they wanted to mess around with them. And then it's available from these labs. I guess not really on the outside internet, but to practice with a Linux machine. Because you will find most programmers tend to use Linux machines to do the development. There's reasons for that. But you might want to get started with Linux machines. So there's some Linux machines you can just start working with. And if we do Python, that should be installed. Oh, Python 3. Oops. Clear. Type Python 3. Looks like he's got 3.10.7 on there. So Python's already installed. 3.10.7 was from last July. That's very out of date. I never even thought about that. 7 came in July. That last number doesn't have to line up. Just in case you thought that was a coincidence, I was teaching a Python course when 3.10.7 came out. That's why I knew that was in July. The 7 is how many times they've fixed bugs. Like 3.10.0 came out in October, and then I found a bug a couple months later, found some bugs, fixed
Versions.
in 1 and so on. So it has Python on it, so you can do the stuff from this class. You can run the Docker containers. Git. Oh, let me make a folder. CD documents. Make their delete. So go ahead and delete. And git init dot. Oh, sudo apt install git. Now it has GitHub. I was just going to run that same Docker container we just created since I'm already on here on a Linux machine. So if I go to Git, edit this folder. Alright. Branch dash in. I need that global. Big dash dash global.
Hmm.
Init default branch. And if you, I did not have that memorized, you'll notice that command I just typed in is in the error message.
Oh, okay. That's-
They didn't have that memorized. It's written right in the error message to do this if you want something other than master. Okay, so now git init dot. So reinitialize it with main branch. So now git remote add origin https://github.com/Francis-Chris5. Same place we just put it, right? And then SDEV 220-spring 2023. And we need the .git extension because we're not going there we're not going there in the browser. We're doing stuff in the terminal. We need the extension. Then git pull origin main. So there's all those files. We have the stuff to make Docker. So we need to install Docker here. Can I do that from sudo apt install Docker? I'll be really surprised if this doesn't work. Okay, yes. This one, Docker. So I hadn't installed it that way before. I just did the sudo. If you haven't used Linux before, that's super user do. So that's your top level privileges. So you don't have to go log out and then log in with a root user where you have admin privileges. That's just immediately super user who has permission to do everything, do some stuff. APT is a repository. There used to be apt-get but they got rid of the -get. It still works if you type that, but that's a repository we only pull from because there's a very small number of people that are allowed to push to the apt repository. So they got rid of the git because that's the only thing people are allowed to do anyway. So we'll have our super user, top level privileges, look at this repository and install Docker if there's something called Docker on that repository. It found it, installed it. So now we have Docker on this machine. Clear this. So now I should be able to go Docker build -t. I would have to go in that folder, don't I? CD Dockerize. Because it's still the same repository we were using a moment ago. And definitely run out of room, but hopefully we already saw these commands. There's the same ones we saw. Docker build -t paycheck dot I thought I just installed it.
Yeah, it said it was successfully installed.
Maybe I need to restart. How long would a reboot take? Well, it might take a minute to reboot it. It needs to restart, but we don't need to watch a restart. You saw the instructions. Does anybody doubt me that we would run this exact same thing here? Right? We have a virtual machine. We can load a virtual machine on any machine. We can run a virtual machine here, but after installing it, I guess I need to, I think I have to restart it. And I want to show you something else before we wrap up. So I'm going to type in exit to leave the leave that secure shell connection. You see, we're back to the PowerShell prompt. That's there to mess around with if you haven't used Linux before, so you might want to give Linux a try. I'll show you this new thing they have on Windows soon. Windows included virtual machine.
What happens if you forget to exit?
It would stay logged on. There's only one account. There's only the student user account. So whoever went there next time, it would probably reset it whenever they tried to log on. We can also do remote desktop, the Windows machines. So there's a remote desktop connection or RDP built into the Windows machine. It's really small there. I think that's the same one. Better go to 10.81.110.213 or 14, 15, 16. Then yes, we do want to connect. And then we get GUIs to work with. Which there's no, they did that to me earlier. When I went in the first time, it's like the machine, it's like the monitor, the virtual monitor is asleep. So you have to move your mouse so that it wakes back up. Even though we were just.
That definitely makes sense if it's in a closet and because we just used something else. We didn't access this.
Oh, yeah, these aren't actually in the closet. They're sitting on a desk here in the room at in 162. So I'm remote accessing a machine in a closet, which is remote accessing a machine in the room I'm in. A couple steps along the way there. If I open files, we can see it's the same machine here. When that opens in documents, there's that folder I just downloaded and all this stuff from the repository. So once the machine reboots and Docker is actually installed, I'm pretty sure that's what it was. All that would work. I'll just delete it from here. Delete.
You're deleting that remotely?
Trash.
Are you deleting that remotely?
Yes.
Wow.
That was just the repository we just brought up. Where's trash on the go to? No idea where the trash is. Oh, there it is. Delete it. Because it doesn't need that's just pulled down from the repository. We'd have to reboot and stuff and a whole bunch of steps. And I mostly just wanted to point out that these things are here. So that'll work. So then we can close out of the remote desktop. Okay. And we can sign off of this one. If you remote access the ones in the closet, make sure you go to sign out, not shut down. But a lot of people are just in the habit of that. So we do open the closet door and check every couple of days to make sure the power button, check to see whether the power button needs pushed or not. But that's there, and it's also good practice with remote access.
Oh my God.
Windows X. Sometimes I will show Windows subsystem for Linux. Windows includes Linux virtual machines now. They're all networked together. It thinks it's an Ethernet a network connected with Ethernet to all the Linux virtual machines and stuff. So you can also have Linux on your Windows machine now and run native Windows apps, or sorry, run native Linux apps on Windows. So like if I go to Kali, a couple of y'all might recognize this. Some of y'all probably never seen this before, but if I open Thunder, it's definitely not Windows started before, right? It's a Linux application running natively on Windows. So Windows subsystem for Linux is really, really nice. You might want to look into that. If you have a Windows machine, and you can have lots and lots and lots of them already networked together, so you don't have to go set up virtual machines. But the main thing for tonight was the Docker stuff. Does anybody have any questions about that? I see head shaking no. I'll still wait 5 seconds like normal, or it's almost been 5 seconds. Okay, so we still have about what, 50 minutes left in our scheduled block of time, where your schedule should have a time slot marked off, says learn Python. Practice that Docker stuff. There's not step-by-step instructions, just make an application and then do what we did in the second video here tonight, which you can get to if you go to Ivy Learn and then Zoom. There's a link for cloud recordings, and you can watch what we did tonight if you didn't catch all those steps, or look back at, you know where the GitHub repository is, and look at the example if you weren't following along. And that's basically what your thing is. You'll provide the Python scripts, all the scripts necessary for whatever application you feel like writing, the requirements.txt file, and the Docker file is what you'll submit. And then I will build it on my machine, and I will build it and run it to grade it, right? And read the code. I read the code too. But I read the code and run it. I think like last week I did do one that was just completion graded, but I did read all the code still. I just didn't download it and hit run. I read through your code, your bug reports, and everything you had on the repositories. I just didn't download them and hit run because it felt like time was getting compressed, getting tight, and there was like the little notifications on Ivy Learn told me there were 27 assignments to grade for this class. I was like, okay, these 9 can be completion graded. So that got it done really quick, but I still read all the code you wrote, and looked to see if there was any questions and comments or bug reports and stuff like that. So some people did get answers to questions, even though the assignment said, or even though the comments in the grade book said this was only completion graded. But I don't hear any questions. So give the Docker stuff a try, practice with that. We will see the traditional installers before long as well. And to use a traditional installer to just install Docker or some sort of container is great. Or you can run containers on the cloud and just deliver them across the network, and it's good to go when it comes across that network connection. Otherwise, that's it for this evening. I'll see you all on Wednesday, and we'll do the next step of Django, where we get to page templates. And then we can make really nice looking stuff quickly.
Thanks, Chris. Bye, guys.